When do you think AI will be able to deliver a AAA game end to end with basically no human interaction except the prompt and then the sign off? So this isn't the problem that I set out to solve, but I'll show you the whole process. But TLDR, good stuff up front. What we are anticipating, and when I say we, I mean me and ChatGPT o3, is basically that by around 2030, a typical prompt, such as in, ChatGPT o7 or o8 or whatever is out by then, probably going to be a different name. Who knows? OpenAI has a wonderful naming convention. But anyways, your friendly AI will be able to deliver a AAA polished game with a single prompt by around 2030. Now, to work up to that, I'll show you all the math that we did because there's quite a bit. The AI is jerking, right? So it's the acceleration is still accelerating, but it's tapering off, and we did the math to show that too. So, however, in 2026, we think that AI will be able to autonomously set up a Shopify storefront. So that's not too far outside of the realm of possibility right now. That could be by the end of this year. So technically like January 2026. But yeah, so total human time is just, 5 minutes to type the prompt. Then 2027, we're thinking that the level of machine autonomy is going to be up to writing a whole technical book on its own, including slides and educational content, which would be great. I have a lot of stuff that I want to teach the world. So that would be video synthesis, audio synthesis, doing the technical research and that sort of stuff. You can get most of the chunks, but with a variety of tools today. But certainly a 35 chapter technical book would still require quite a bit of human in the loop feedback right now. So we're looking at 2 years before that's fully autonomous. 2028 would be a feature complete mobile banking app. So I thought that was a pretty cool guess based on all the underlying capabilities that O3 and I are anticipating. And number 2029. In year 2029, we're anticipating an entire indie game. So an entire indie game, soup to nuts, with basically just a prompt. And then the following year, it'll get up to either AA or AAA open world title, like No Man's Sky or Cyberpunk 2077. Good grief. So anyways, all right. So that's the bottom line. So now I want to spend a whole lot of time unpacking all the math and science that we used to get into this. So let me show you the slide deck that I had prepared. And then I realized the slide deck is kind of missing the fun stuff, but you're going to learn a lot about jerk today. So Jensen Huang a little while ago said we're at Moore's Law squared. So this was late last year. And the math actually has been more like Moore's Law cubed. And I'll show you how we got to that math. But basically, yes, that was not hyperbole on his part. That was an observation that the acceleration is accelerating. So if you're not familiar with jerk, there is basically orders of derivatives. So position is where you're at in time and space. Velocity is the rate of change of position over time. So that's like you're moving at 10 meters a second, right? Acceleration is the rate of change of velocity. So gravity is acceleration, 9.8 meters per second per second. And then jerk would be as if you're accelerating, if the rate of acceleration is also changing. So then you say, okay, well, if the acceleration is accelerating, because it's like, okay, maybe gravity starts at 9.8 meters per second, 9.8 meters per second per second. So that means you're going your velocity increases by 9.8 meters per second every subsequent second. But then what if that acceleration coefficient actually changes? So instead of in the first iteration, you're accelerating at 9.8 meters a second, in the second time step, you're accelerating at 12 meters a second per second. So that would be jerk. And so the reason, if you take a big step back, the reason that everyone has always been too conservative with their AI predictions is because everyone has assumed that we're only experiencing acceleration, which Moore's Law alone is acceleration, right? You double every 18 months, basically. So your rate of progress, the number of flops that you're adding per dollar, is accelerating. But with AI, you have multiple factors accelerating on top of that baseline acceleration. So therefore, we have jerk. Now, you might say, okay, well, what if that accelerates? Then you have snap, crackle, and pop. We did run the math, and we don't think that we're going to see any snapping unless we have a fundamentally new paradigm like photonic computing or quantum computing or that sort of thing, or some other kind of fundamental breakthrough, but it's not seeming particularly likely. Either way, jerk actually accounts for a lot of what we've been missing. So let's get into the data. First and foremost, this is the graph that really set it all off. So this is based on the meter, so METR data, which shows that the temporal length of tasks that AI can do without human help is increasing exponentially. But what we've seen is that over the last, basically the last 18 months in 2024 and 2025, that horizon has been doubling every 4 months, whereas up until now it's been doubling every 7 months. So this is what you'd call acceleration. So it's doubling every 7 months. So the rate of doubling was 7 months. So that's acceleration. But now that rate has shortened to it's doubling every 4 months. So this is a good example of jerk. So the length that AI can do autonomous tasks is jerking. The acceleration is accelerating. So this is what kicked the whole thing off, and I'll show you the whole conversation that I had with O3 at the end, because that's for the nerds. If you really want to get lost in the weeds, stick around to the end. But I'm just going to show you the data nice and clean up front. So this is the first derivative, or this is the first kind of acceleration. 120 years of Moore's law. It's not slowing down. It hasn't slowed down. It's not going to slow down unless we're nowhere near the fundamental limits of physics and thermodynamics, so on and so forth. So this is the first computational substrate. Next, we see that training flops are going exponential. Now, this is largely a function of money. Basically, the more money you put into AI, the more flops go into it. So this is not necessarily pointing to something that is fundamental, but it's still good data. When we talk about fundamental acceleration, we're saying, for instance, Moore's law is each of these steps is a fundamental advancement in the science of computation. In the era of the integrated circuit, this is all silicon wafer technology. Before then, it was transistors, vacuum tubes, relays, which were electromechanical, and then before that, purely mechanical computation. So unless we have another step change in terms of how we even conduct computation, we're going to be on this trajectory. And we've been on this trajectory for quite a few decades now, but it's possible that we switch from integrated circuits to photonic or thermodynamic or something like that. Either way, that's kind of baked into the assumptions that we're making, because we're basically saying, okay, Moore's law is a fixed assumption. So the computational substrate might change. But that might not actually change transistor density. We'll see. Or the cost of per flop. So this is calculations per second per constant dollar. So basically, as time goes on, you can do more calculations for every dollar. That is the prime generator function. That's like, how much intelligence do you get per dollar? That's what we're really measuring. So then, as I mentioned, this is more a function of dollars. This scaling AI by itself does require some algorithmic stuff, which we'll talk about. But I just want to point out that the money input is a primary constraint here. Now, next, this is the chart that everyone has seen recently that shows that AI benchmarks are approaching saturation point. And saturation just means it's at human level performance, but many of them are surpassing human level performance. This is not just a matter of dollars. This is actually indicative of underlying fundamental improvements. So whether it's image recognition, reading, code generation, those sorts of things, you see a bunch of these things. This is actually another good example of jerk, where AI problems that started earlier have taken longer to scale up, but more recently they're scaling up faster. So the rate of progress is accelerating. You actually see jerk in this chart as well. It's very obvious. You can see it just from the slope or the average time to saturation from when a task began to when it became fully saturated. Reading comprehension was basically at 0 in 2016 and then surpassed humans within a couple years. So yeah, this is another example of jerk. Next up is the AI is becoming reliably more autonomous every 7 months. So this is the meter data, which showed 7 months. But if you trim it down to just 2024 and beyond, it's actually every 4 months. So this goes back to that previous graph that I showed you, where we actually do see that we do see evidence, real-time evidence that acceleration is happening. Now, one thing that I want to point out is that number one, this is 50% success rate. So it's not that it's always able to do that with 100% success rate. You're looking at median success rate, but also it doesn't necessarily take the model as long as a human does. When they're looking at each of these tasks, they're like, how long did it take a human to do this, and then can the AI do it on its own? They're not saying that the AI was fully autonomous for 4 hours, or in this case, an hour. It's just that's how long it would take a human to do it. They're already faster than humans, so that's a really important thing to point out about this data. Now, if you just look at the last few, it's jerking. So that's the last of the real empirical data. Everything else that I'm going to show you was modeled by my work and mostly by O3. So when we're talking about like some of those predictions, like by 2028, it's going to be able to do a full banking app, and by 2030, it'll be able to do ship a AAA game with only human sign off. Here's some of what we're looking at. So number one, this is Fortune 500 generative AI adoption. As of today, it's at 70%, and it's been growing at about 6% per year. So you extrapolate that out, and you see that Fortune 500 generative AI adoption saturation will hit about 90% by 2029. So 2028, it'll be close. 2029, 2030, you're going to be close to 100% Fortune 500 adoption for generative AI. Now, what I will point out is there's two things about this chart. Number one, this is a lagging indicator of AI capability because Fortune 500 companies are phobic of new technologies. And this is also a very low threshold because this is basically saying, are you officially using generative AI for at least one function? So as of today, Fortune 500 companies are using generative AI for at least one function, but that means 30% are not using officially using generative AI for any functions whatsoever. So the level of saturation is still going to go up over time. However, once you get to the 2028, 2029, 2030 point, that saturation is going to be getting to a point of super saturation where you use it for everything. Consider the history of the internet and Ethernet. So this is actually one of the ways that we kind of estimated where's that saturation point was we looked at the history of Ethernet. So Ethernet is, your Cat6, your Cat5, Cat6 cables that you plug in. That was not ubiquitous until it hit about 100 megabits per second. Then every bit beyond that just made Ethernet even more compelling as the default local area networking technology. So basically what we're saying is that by 2028, generative AI will be so compelling that it'll be the default choice in the same way that Ethernet became the default choice for networking. So that's when you're going to really start to see a major tipping point in terms of AI capabilities and robust business deployment. All right, moving on. So based on all the historical data looking at the entire modern history of deep neural networks, we estimated the jerk coefficient over time. So this is based on empirical data, and I'll show you all of that, all those calculations in the chat. But for now, you can see that jerk is slowing down. So it has gone down pretty significantly. Now the scale is not quite. The scale is slightly deceptive. It's not at 0, and I'll show you where we're forecasting it to go in a second. But the point is that we've estimated that jerk has been declining since the beginning of the deep neural network era. So it was fastest at the beginning, but it is slowing down. But we still have a jerk coefficient, meaning the acceleration is still accelerating. It's just the acceleration of acceleration is slowing down, if that makes sense. So here's the sigmoid curve that I've been talking about for a couple of years now, but it wasn't a sigmoid curve that's going to say, oh, we're going to plateau. It's that we're trending towards a normal exponential rather than a super exponential. So based on the historical trend, we're modeling the decline of AI capability jerk. So the acceleration of acceleration will start to peter out around 2026. So we've got about another year before the acceleration of acceleration dies down and we have just ordinary acceleration. This is, of course, assuming that we don't have another breakthrough. As many of you have pointed out, it could be a step function of step functions where it's like, okay, yes, the current schema might die out, but when you look at the historical data, even with new schemas, we're still seeing a decline of jerk. So the era of the fastest AI acceleration could be ending within the next year or two. But then we still have ordinary exponentials. Now, that's not to say that the value prop will not continue going up, and I'm really excited to show you that in just a second. So this is the simplest way to explain jerk. So jerk is the cost of intelligence is going down. Now, token cost has gone down exponentially. Meanwhile, the utility per token has also gone up exponentially. What I mean by that is that consider the cost of a token of GPT-2 or GPT-3 wasn't particularly intelligent, and it was also 6 cents per 1,000 tokens, which now buys you 1 million tokens or however much it is. Cost is basically per token is trivial. When I got my first training tranche of GPT-3 tokens, it was like, you have 40,000 tokens. And that was a big gift back then. You have 40,000 tokens to experiment with. And it was like, wow, I don't even know what I'm going to do with all this. And then a couple months later, a fine tuning job was like 100,000 tokens. So anyways, now as token cost has gone down, they've also gotten smarter. A GPT-2 token back here in 2020 or GPT-3 token was pretty dumb by comparison to an original chat GPT token, which was about 1,000 to 3,000 times smarter in terms of total utility than just GPT-2 or GPT-3 on its own. And that has only continued to go up. Now, I'm not quite sure what explains the drop. I think that the drop right here is because we've introduced reasoning models. And so reasoning models are slightly more expensive because they use a lot more tokens. So they actually dilute the utility per token a little bit. I'm pretty sure that's what caused this drop right here. Now, that will hopefully be a temporary thing, but you also see where there was this very clear sigmoid curve where the utility per token is starting to slow down. And I'm not going to say that this reversal is a permanent trend. I don't think that that's going to be the case. I think that it's going to be refined into it, and that reasoning traces are just going to be baked into the future models. So you won't even see the reasoning. Anyways, moving on. So this is the grand finale. This is the big data, the big kahuna data that when we ran this, we said, okay, based on everything that we're seeing, what are we actually expecting AI to be capable of doing? And what we tried to do was bake everything in from intelligence, which is benchmark saturation and task complexity. So that's like how long of a task can it do on its own. We tried to bake all of that into utility per dollar. And then we plotted it out over time. So based on current, just ordinary middle of the road projections, the middle of the road here shows that in the next few years, basically, so okay, let me give you some intuition as to what this graph shows. 2020, this is the transition from GPT-2 to GPT-3, right here. So GPT-3, plain vanilla, original is released. Good old Da Vinci model. So it had a utility that was basically just a little bit higher per token than NLP stuff, but NLP stuff was still much cheaper. NLTK could run on a calculator. GPT-3 could not run on a calculator. So its utility per dollar was actually lower than other NLP processing technologies like NLTK and those sorts of things. So GPT-3 was actually not worth using for basic NLP tasks. It was still good for list generation, summarization, and a few very, very small tasks. But remember that you were limited at first to 1,000 tokens and then 2,000 tokens. And finally, when we got 4,000 token windows, that was huge back in GPT-3. Did we actually... Maybe we didn't get 4,000 token windows until 3.5. I don't remember. It's been a long time. Now we have million token windows here just 5 years later. So you look at the function that goes up. So relative utility of 10, 100, 1,000, 10,000, 100,000, a million, 10 million, and so on. So you look at, okay, this is where GPT-3 was. A couple years later, we had ChatGPT, which plain vanilla ChatGPT was infinitely more useful than GPT-3. That's why it blew up. So you basically went up by an order of magnitude in usefulness. Couple years later, 2024 is when we first. Well, this was when we had chat. Some more of the integrations. Oh, by the way, one thing that I didn't mention in this was all the integrations, such as RAG, tool use, all that kind of stuff. That increases the utility per dollar, and that's actually one of the cheapest ways to increase utility. So here we are, 2025. We've introduced reasoning models, and so this is at about 10 to the 3.5. So this is about 3,000 times more utility per dollar than GPT-3, if this back of the napkin math adds up. So then moving forward, we broke it down into 5 scenarios. So the worst case scenario basically is all paradigms basically peter out, including Moore's law. Probably not going to happen. Worst case scenario, it has like a chance of like less than 0.1% of happening. Like TSMC shuts down, NVIDIA shuts down, OpenAI shuts down. If pretty much everything goes wrong, then by 2035, AI will only be 30 times better than it is today. The bad case scenario is basically all acceleration, all assumptions about jerk prove to be false, and we also hit the lowball margins, kind of the left error bar of every trend that we identified. And I did show you we do have a lot of data. So basically, if all of these are off by a little bit, and we take that kind of very pessimistic view, then we're still looking at AI being 300 times more powerful than it is today by 2035. Now, the middle of the road one is 3,000. This is another, actually, no, I think I've got it wrong. But you can see that we're up several more orders of magnitude. So we're at just above 10 to the 5th, whereas we're at 10 to the 3.5 right now. So that's another 1.5 orders of magnitude above where we're at today, which is about that's about the jump between ChatGPT and where we are today. And so then the middle of the road is that in 10 years, will be another order of magnitude. So basically, your run-of-the-mill AI will be as much better than O3 is from ChatGPT was 2 years ago. I don't know if that's making any sense. Then in the more optimistic scenario, and honestly, after looking at the ramifications, I'm thinking that the optimistic scenario is actually much more realistic when you look at these arcs. Then you're above 10 to the 6th. So we're at 10 to the 3.5 right now. Over the next 15 years, it's entirely likely that the jerk keeps jerking, right? So this is the optimistic scenario is the jerk keeps jerking. We figure out numerous more layers of improvements. And so then we're looking at something that's like 300,000 times better than what we've got today. And then we did the ultra optimistic one, which is snap. So snap would be that the jerk is actually underestimating what's going to happen in terms of utility. And then we end up somewhere around the realm of 5 million times more powerful than AI is today. So that's how we got to those predictions that I showed you at the very beginning. Here's a little quick plug for my link tree. I'm not going to spend any time on it. If you want to look me up, look me up. Moving on. So breaking it back down, we're looking at, this is kind of what we expect based on the empirical data. 2026 agents go mainstream. The first computer using agents are going mainstream today, but that's for cutting edge users. So what happens in 2026 is 1 million token windows become ubiquitous across all platforms. Gemini is already there. OpenAI, Anthropic, they're not that far behind. Tokens continue to get cheaper. But then we also, by the end of this year, so the end of 2025 or in 2026, 50% success rate on autonomous 4-hour-long tasks. So that means sometime in 2026, the AI, now it's not going to necessarily take this long. It might only take 30 seconds. It might take a couple minutes, but it will be able to do tasks entirely on its own that would have taken a human about 4 hours. So that was training like an image classifier, right? So an experienced human training an image classifier, it'll be able to do that all on its own. By the end of 2026, we're expecting that Fortune 500 AI saturation will be at about 85%. Now that's 85 of them will be using at least one function for generative AI. That's not necessarily full saturation. So the pricing, basically the price, the price per outcome continues to drop about every 9 months. Meter horizon still doubles every 7 months. This isn't taking into account that the meter horizon actually looks like it has accelerated to every 4 months. So this is why I think that this whole prediction, is still actually a little conservative, because we didn't even bake in all the data that we have today. We just assumed that the historical trend was what remains, whereas the optimistic trend actually looks like it might still be more accurate. And every time we've tried to model this, we've turned out to be too conservative. So just assume that I'm being too conservative here. 2027 is the commoditization year. So basically, 1 cent per 100,000 token job, 50% success rate on 8-hour tasks. So that's basically an AI can do a full human day's worth of work on a single prompt. So that's 1-shot success or 0-shot success rate. That's not necessarily saying that there's going to be feedback or an overview, particularly if you have agents that monitor other agents or user proxy agents, those sorts of things. So this 2027 is when Fortune 500 penetration crosses the 90% threshold. So this basically says any new software that's stood up is going to be by default AI first software. And if software is not AI compatible, there's going to be a huge pressure to make it AI compatible. The task length curve remains unchanged based on the assumptions that we made. Again, right now it seems like it's accelerating. So that it all could be wrong. 2028 is where we achieve cognitive plateau. So this is really interesting. This also goes back to kind of what I and others have been saying, which is like it looks like 2027 is when we hit like basically the equivalent of artificial superintelligence. And the working definition of artificial superintelligence right now is basically every benchmark we can come up with is saturated. Now, that means accuracy on a single task. That's not necessarily tracking task complexity or task size. If you want to track task complexity or task size, the task length or the meter metric, that's the one that's really important, because the time horizon is the best single proxy that we have for task size or task complexity, rather than single task 0-shot performance. So if you say like, well, Dave, that sounds like a really thin definition of ASI, I agree. Even if we saturate every single benchmark that is ever produced by 2028, that's still gonna have lots and lots of things that it's not measuring, but it's still going to be a signal that represents the underlying utility per token, the underlying intelligence that you're getting per token. So by this time, agents routinely orchestrate day-long workflows, much faster than humans do it. RAG and code exec and everything else, so tool use, is all baked into all SDKs by default. It's going to be kind of like how Anthropic released MCP. So all the best practices and standards are going to be well defined by then. It's all going to be shipped as a default package. Token metering becomes a little like basically bandwidth style. So you say like you have up to 1 billion tokens per month or whatever. So this 2028 is basically when we achieve Sam Altman's idea of intelligence too cheap to meter. That's kind of where we're anticipating that plateau. Now, also, you consider at the same time the models are getting cheaper, they're getting faster, they're getting smarter. So yeah. So now the underlying intelligence IQ headroom is gone. Vendors such as OpenAI, Microsoft, Google, so on and so forth, they have to focus on agenticness or autonomy. And speed and privacy and a few other things, because at 2028, basically you've solved intelligence. It can do all the math, all the science that you need. So then it's how integrated it is, how good its memory is, and those sorts of things become the real primary differentiating factor, which is why at this point, it could do a feature complete mobile banking app on its own, more or less, but it couldn't ship a AAA game because there's just so many more components. There's so many more man hours that go into a AAA game. Now, 2029 is when we hit one, jerk fully disappears. So we're just at basic acceleration, which again, there's a compelling case to be made that maybe this is too conservative already. So this is where all enterprise software is agentic first. This is where if jerk disappears, we decline to typical just Moore's law base. So Moore's law squared or Moore's law cubed disappears by 2029 with our current model. But task length keeps doubling because it's not slowing down yet; it's only accelerating. And at this point, meta orchestration layers become the primary differentiating factor. So rather than having an agent or a fleet of agents or agents that monitor other agents, you have meta orchestration layers, which are agents that independently decide strategy, resources, those sorts of things. This goes back to the ACE framework work that I and the ACE team did, 2 years ago now. So you'll basically have a hierarchy of agents, not just one layer, not just agents with a supervisor layer. You'll have who watches the watchers layer, and you'll have other differentiations. So this is 2029 is about when, if all these trends hold, is about when you could expect it to code up an indie game in Unreal or similar engine and ship it on Steam, mostly autonomously. And then 2030, this is when we reach basically full saturation point. Autonomous multi-week projects reach 20% success rate. That's with a single prompt, by the way. That's zero-shot success. Now, that is when we would expect that, okay, AI will be smart enough and integrated enough to build and ship a AAA game with no human intervention, at least some of the time. So that's a pretty, when you think about how many layers that is, that actually kind of gives you a good idea as to the level of autonomy that we're looking at. And it's all based on data. Now, with that being said, I want to show you, if you're sticking around, I want to show you the full process that we went through to get to this. And I'm going to pause it real quick and get some water because my voice is getting dry. And we're back. All right. So it all started with this prompt here where I said, okay, you know how the margin for AI progress has always been too conservative, et cetera, et cetera. You know, Jensen Huang said Moore's law squared. Could we formalize it? Could we actually formalize how much acceleration we're experiencing in the acceleration? Can we quantify the jerk? And so it thought for 3 minutes. So O3 thought for 3 minutes, which for human thinking, for me thinking time, that's like probably a few hours. So the initial data that it looked up was that the how much work you can buy per dollar of training doubles every 3 months. So, or 3.1 months. So the effective acceleration rate was that the acceleration was doubling every 3 months, or about just over every quarter of year. So I was like, okay, that actually feels about right, because it's like every time we get a step change, it's like, you know, remember when ChatGPT came out and then subsequent versions came out, and it's like, hold on, this outstripped what we expected to get. And so every 18 months, we get a new batch of foundation models. It's like, that was faster than we thought. But that doesn't explain, that's like, okay, well, if the effective capability in terms of all the integrations and everything doubles, if the rate of acceleration doubles every 3 months, that didn't quite feel right. Close, but it didn't feel right. I said, okay, please double check. I said, try to prove yourself wrong. And so then it looked at several different epochs. So there's the 2012 to 2018, there's 2018 to 2022, and then 2022 to present. And so then what we found is this is where we first saw evidence that the jerk has been decelerating, because the earliest epoch of deep neural networks was the fastest. This is when we saw, from 2012 to 2018, this is when we saw the fastest doubling time of acceleration. However, every epoch since then has been decelerating. So this 6-year batch was 3.4 months. Then the next 4 years was 5 months. And then after that was, 6.4 months. So if the acceleration has actually decelerated by a bit, then it's like, okay, the jerk is slowing down, which is kind of what some of us have been afraid of. Now, remember, even if the jerk coefficient disappears, that doesn't mean that that the acceleration disappears. We're still accelerating. It's just the acceleration will stop accelerating. So the global net effect was closer to 3.7 months total. Now, again, this is all back of the napkin math, and you can criticize the methodology 8 ways from Sunday. I'm not standing behind the methodology. This is just like our best guess, and because we're looking at things like MMLU, GMS8K, human eval, and those sorts of things. But at the same time, the charts that I showed you, that's real data. So we're basically just trying to make sense of what is the data telling us. And Jerk does explain some of the margin of error that we've had in terms of predicting AI capabilities. So if we bake that in, then it's like, okay, if we add in the Jerk coefficient, then we can better explain why AI capabilities have regularly surprised us, particularly over the last 3 or 4 years. So moving on, I said, okay, so we're still seeing a Jerk regime over at least the last 18 months, but it's slowing. So TLDR, yes, it's slowing down. And so the idea was, okay, the question became, do we have a constant Jerk or what? Now, some of this we will have to wait and see, because there's always going to be a lag time, particularly as the frontier labs are releasing new foundation models. So we haven't fully seen what everyone else can do. Like DeepSeek R2, once that drops, that might change everything. Although I can point out that the Llama 4 disappointment, that might actually be another data point showing that maybe the Jerk is slowing down. It could also be that it was a mistake made by Meta and Jan LeCun. Jan is famously against LLMs. So if he said, oh, well, I don't want to do any more with LLMs because they are not good, with his French accent, I hope that you don't mind that I tried a Jan LeCun French accent. But anyways, if he said that, then maybe he sabotaged Meta. Not on purpose. I'm not saying it was malicious. I'm just saying because his attention is elsewhere. So TLDR, still a Jerk regime, but not the wild 20-year -3 roar of 2023 to 2024. Anyone planning hardware policy or product timelines should treat that down Jerk curve as their baseline and keep recalibrating every quarter. So then what we did was we pivoted to say, okay, like what are we actually measuring? Because you can say, you can look at benchmark performance and say, okay, every token is getting smarter. So then we say, like, how are we measuring intelligence per dollar? And then we also said, like, okay, well, the tokens are getting cheaper, but they're getting smarter. So this was the intuition here. And so then we're trying to define a utility function. So if you go all the way back, GPT-3 DaVinci 2020 had 43% on the MMLU, 6 cents per thousand tokens. GPT-4 had an 8K window. 3 years later, 86% on the MMLU, so doubled its percentage, but that's many orders of magnitude more intelligence. And it was half the cost per thousand tokens. GPT-4 1 Nano 2025 is a little bit less on the MMLU, but it's infinitely cheaper. So the intelligence per dollar relative, indexing on GPT-3 performance, means that GPT 4.1 Nano is 2,700 times more intelligence per dollar. Now, again, criticize the methodology all you want. I agree with you. MMLU is not necessarily the best benchmark, but you can apply this methodology to any other benchmark that's out there. So moving on, so bottom line, yes, the intelligence per dollar lens squeezes the whole stack into a scalar, and that scalar is exploding. Even with the recent deceleration in raw compute growth, a 2 to 3 order of magnitude leap in just half a decade means the Jerk regime is still very much alive where it counts. Capability delivered for a buck. That's the most important thing. Even if the AI is not necessarily getting smarter at the same rate, it's getting cheaper and it's getting more integrations, so the capabilities are still exploding. Built-in Python interpreters, built-in tool calling, all of those things still dramatically increase the capabilities of the AI. Memory regimes, RAG, those sorts of things all increase the utility of the AI. Also, token window. Don't underestimate the value of a larger token window, because that is like effectively makes it much smarter because it can read more primary sources. Attention mechanisms, all of those things. So then we started talking about intelligence saturation. Unfortunately, O3 didn't realize that Gemini 2.5 was out, so I had to remind it and like, no, check against 2.5. So this first time it compared Gemini 1.5 Pro against GPT-4o, and I said, look up Gemini 2.5 Pro metrics and benchmarks and compare to O3. So then it's like, okay, cool. So the long story short was this query is where we started realizing that there are differentiating factors between models. So a lot of you out there are like, Gemini Pro is the best. Gemini Pro fits a different market niche than O3. Gemini is more powerful when it comes to long conversations and large context. It's also it's almost as intelligent, but it's faster and cheaper. So its utility actually goes up quite a bit. O3, however, is more agentic and has more tool calling. So on the one hand, Google is focusing on scale, right? How cheap can you make the model? Because I think at the end we said that Gemini is about 3 or 4 times cheaper. Yeah, so Gemini is brutally cheap on inputs, 1.25 per million tokens, and moderate on outputs, $10 per output token. By contrast, O3 asks $10 in, so it's actually what is that? That is 8 times more expensive. So O3 is 8 times more expensive on the input and 4 times more expensive on the output. But so all told, Gemini's dollar per token is 5 times lower. However, O3 has much more mature tool calling. So that's function, file search, code execution, web browser, RAG, all of that stuff, which means that O3 still has more utility depending on your task than Gemini. But Gemini certainly beats O3 hands down on those other cost utility metrics. So if you want speed, cost, and token windows, if that's your bottleneck, Gemini is 100% the way to go. So the empirical 3 to 4 months jerk still describes reality today. Gemini in particular slashed input pricing tremendously versus 1.5 only 6 months ago, and O3 pushed benchmark ceilings another 2 to 3% while doubling tool breadth in the same span. So if you just look at the difference between Gemini 1.5 Pro and 2.5 Pro, and then you look at the difference between O1 and O3, we're still seeing that jerk, but it's not necessarily entirely in fundamental model performance. It is partly in fundamental model performance, namely the token window and the baseline intelligence, but also the integrations. So that's one of the primary things. You see, we're only a fraction of the way through the conversation. For anyone still watching, like, I appraise your endurance, and I know that you guys all often approve of my extemporaneous endurance. So we're going to be pushing the limits here. All right. Anyways, next up, we were trying to in this next turn, I was trying to figure out like, okay, like what are all the different components of it? And so like Moore's law explains one part. So there's hardware economics, Wright's law, algorithmic efficiency. So having the compute every 9 months to get the same token. So basically, the algorithmic benefits mean that you get the same level of perplexity, but it costs half as much every 9 months. So Moore's law is going up. Cost of perplexity is going down. Then you get positive feedback loops. So you also get economies of scale with the margin compression. And then you get other utility multipliers, which are very cheap to add, by the way. So you get function calling, you get RAG, you get tool use, you get API calls, you get code sandboxes. Those are actually, I think, the unsung hero is that any foundation, any frontier lab watching this, you really need to double down on the agentic components, such as function calling, RAG, structured outputs, code sandboxes. Those allow a model to punch way above its weight in terms of intelligence and cost. So that really dramatically adds to the utility. So basically, we came up with a new utility function. So you've got utility is hardware, algorithms, margin, and then tooling. So this is a really simple function that anyone can adopt to understand, okay, what is the total utility of an AI platform, not just the model, but the entire product. And the fact that Meta is ignoring the rest of the product stack, I think means that they're going to get left behind. Their Meta's entire theory is we're just going to release, frontier models that are just plain vanilla models. And Llama 4 proves that, like, no, you actually need to invest more. So I think that Meta took a wrong turn, and I think that the top competitor is still OpenAI because they're doubling down on all the agentic frameworks around it. I have long been saying that treat the LLM just like an engine. You still need brakes, you still need steering, you still need safety features. It's just a power plant. It's just a cognitive power plant. All right, moving on. This is where we started trying to figure out where jerk might diminish. So I basically said, diminishing jerk over the last 18 months. Can you predict where it will taper off? We think around mid 2026. So long story short, the frontier run flop and algorithmic halving time each quarter. When either slope flattens decisively below 1x per year, you will know the super exponential era has closed. So late 2026 is basically when we kind of expected that. Although, again, depending on which data you look at, that still could be too conservative. And now I started asking it to generate the graphs. So you saw this graph earlier, which is just modeling the decline of jerk. But again, this could be extended through December 2027 or longer. It could go through 2028 if things like task length continues to go up or continues to accelerate. It could also go up faster if integrations take off. Because right now, O3 does like 600 tools, but what if it gets to 600,000 tools, right? That seems within the realm of possibility. Oh, and we also haven't even touched multimodality. This is under the current regime of LLMs. So here's some of the other graphs that I've showed you. This one is just the utility per dollar compounding. So this is the total utility based on that other that formula that I just showed you that has the 4 components. So utility continues going up, and it will of course continue to go up indefinitely. If it doesn't go up, we're not going to invest in AI anymore. We might get to a point of diminishing returns, but we're still jerking, right? The acceleration is still accelerating, so it makes sense to keep investing in AI. Here's a couple other graphs that were basically showing the same data. I just wanted to extrapolate it out a little bit further. So we do kind of anticipate that the total utility per token might start to diminish, but this will be, I don't know if I believe that. I think that we're going to see compounding returns for quite a long time. But this is just under the current regime. And I believe that's the majority of the valuable stuff. And a lot of this was clarification conversation on my part. And then finally I was like, okay, just show me how it's going to go. If we look total factor utility per marginal dollar on a logarithmic scale, this is what we got. Now, like I said earlier in the video, the snap and the optimistic, this I think is more realistic as to where it's going to go. Now, you might look at this previous one and say this is a straight line on a logarithmic scale, so maybe even the snap isn't good enough. I could be convinced of that. Again, this was just back of the napkin math. So with all that being said, the long story short was all your derivative are belong to us. This is where we're going to end. So thanks for watching to the end. It's been quite a marathon. TLDR foundation models, you need to focus on those agentic components. You need to focus on those integrations, API calls, sandboxes, search, RAG, all that stuff. That's really right now the big differentiating factor, as well as task length and complexity, not just single task accuracy. All right. Thanks for watching. Cheers.